A robot's primary object is movement, isn't it? So, today we'll discuss guiding robot movement. What are the algorithms and languages that are being used so that a robot can move like you are watching on the screen? They not only move their bodies, but they can move their lips, they can move their eyes, they have very special facial expressions, and etc. Hello and welcome to Students, a channel for intelligent and curious people like you. Before we proceed, let me tell you one thing. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, tons of thanks for your support. Now, the guiding robot movement, that is our topic. It involves determining the robot's desired trajectory, velocity, and acceleration based on its current state, the environment, and the desired goal. This process often involves a combination of algorithms and programming languages. Now, what are the combination? What do we mean by the combination of algorithms and programming languages? Let us try to understand it first. First of all, common algorithms and their roles. There are common algorithms like path planning algorithms, motion control algorithms. These are two main algorithms that basically control this guiding robot movement. And learning and path planning algorithms, it involves three typically very known algorithms that on which we have discussed before. One is a search, which efficiently finds the shortest path between 2 points while considering the cost of each step. And RRT, that means rapidly exploring random trees, explores the search space efficiently, especially in complex environments. And third is potential field methods. That means create a potential field around obstacles and the goal to guide the robot. I just discussed this in my previous video. APF, okay, artificially potential fields, APF. So now another algorithm is very important, that is motion control algorithms. PID, that means it calls proportional integration and proportional integral derivative control, a classic control method used to regulate the robot's position and velocity. And second is model predictive control, predicts future system behavior and optimizes control inputs to achieve desired performance. And trajectory tracking control, that means ensures the robot follows a planned trajectory accurately. Now, what are the programming languages and tools? The choice of programming language and tools depends on factors like the robot's hardware, the desired level of abstraction, and the team's expertise. Here are some common options. Let me tell you about the C language and C++ language, low level languages. These are low level languages used for real time control and direct interaction with hardware. And next comes Python, very high level language with a rich ecosystem of libraries for robotics, machine learning, and data analysts. Third is ROS, that means Robot Operating System Language, a flexible framework. It's a flexible framework for building robot applications, providing tools for communication, perception, planning, and control. Next is MetaLab and Simulink, powerful tools for modeling, simulation, and control system design. And the third one is Gazebo, which is a 3D model simulator that can be used for testing and debugging algorithms. Now, a simple robot control system is based on many things. I mean, first is path planning, that means using search algorithms to find a collision free path to the goal. Second is trajectory generation, that means creating a smooth trajectory that the robot can follow. And the third one is motion control, which is using PID control to regulate the robot's position and velocity along the trajectory. Now, the system could be implemented in C++, remember C++ language, for real-time performance, using ROS for communication and integration with other components, and utilizing MetaLab and Simulink for simulation and testing. These are very complex process, of course, and it requires a lot of efforts, a lot of work, and a team always works on the whole project. Several people, we need many people to work on this project. In summary, guiding robot movement involves a combination of algorithms for path planning, motion control, trajectory generation, etc. The choice of programming languages and tools depends on the specific requirements of the application. We will discuss it in my future videos also. So don't worry about it. If you are really interested in learning about these algorithms and especially the how we use these programming languages, we will discuss in detail in later videos. We'll talk about the choice of programming languages and tools for robotics. It has evolved significantly in the last 15 years, and the video you are watching on the screen of robot, you are watching the robot on the screen is a Japanese robot, and it was built 15 years ago. Okay, and in 15 years we have traversed very meaningful path. I mean, that this journey was has been very meaningful for artificial intelligence and robotics, and it is primarily driven by advancements in hardware, software, and open source communities. We will talk about it and get into that topic. So stay tuned and stick around till the end. Now, how it evolves. Okay, and so that from those 15 years back, those robots we are watching on the screen, to the modern humanoid robots, how it evolves. Okay, first of all, increased use of high level language. It's a very important issue because Python has become a popular choice due to its readability, ease of use, and extensive libraries for robotics, machine learning, and data analysis. Its versatility and large community have made it a go-to language for many robotics projects. And second tool rather, not language, is MATLAB, we also call it MATLAB, and Simulink, okay, or Simulink. These tools continue to be widely used for modeling, simulation, and control system design, especially in academic and research settings. We will talk about these things and how they work in our future videos. Of course, if you are really interested in artificial intelligence and robotics, then these videos will definitely come for your need to serve your interest. I mean, so rise of open source framework, that is very important also. Robot operating system, or ROS, we call it in short ROS. It has gained immense popularity as a flexible framework for building robot applications. It provides tools for communication, perception, planning, and control, fostering collaboration and innovation within the robotics community. Second is Gazebo, a 3D robot simulator. I will talk about Gazebo especially in other video, and I'll show you how it works. It is a 3D robot simulator that has become an essential tool for testing and debugging algorithms in a simulated environment. Number three is integration with machine learning and artificial intelligence, or AI. In this case, TensorFlow and PyTorch. The integration of these machine learning frameworks like TensorFlow and PyTorch has enabled robots to perform tasks such as object recognition, natural language processing, and decision making. Now, deep learning also has a very important role in this category because deep learning techniques have been applied to robotics for tasks like perception, navigation, and manipulation, leading to more intelligent and adaptable robots. Okay, so what we see in the in our current scenario, I mean, those robots that are almost look like humans, almost act like humans, talk and speaks our language, answers our questions. These robots, basically, deep learning has a very interesting role. I mean, responsibility in building such robots. Now, fourthly, I will talk about cloud computing and AI and IoT. Of course, that means you know cloud robotics. That means the use of cloud computing resources has enabled robots to access and process data remotely. So you can remotely control a project from sitting at your home, and someone, or your team working on the other side of the globe. You can access process data remotely, improve scalability, and of course the performance of the robots. And IoT, Internet of Things, that means robotics is increasingly integrated with IoT devices, allowing for better data collection, analysis, and control. Fifth one is hardware specific tools and libraries. Arduino, Raspberry Pi, and this they are very low cost single board computers. Okay, and they have become popular platforms for robotics. Providing a flexible and accessible way to develop and deploy robotic applications. And hardware specific libraries like frameworks also have been developed for specific hardware platforms, simplifying development and reducing time to market. That means you can create robots in 3 months or in 6 months. It will not take more than 2 years or 3 years now, so that you can bring it to the market faster than before. Number six, and the last one, is the focus on real time performance and safety. Of course, safety is a big issue, because real-time operating system, that means which we call also called RTOS. RTOSs are increasingly used to ensure deterministic and predictable behavior in robotics applications, especially those requiring real-time control, right? And safety standards are also very important, because safety standards and regulations are becoming more important as robots are deployed in environments with humans. So, for our safety, it is very important. In summary, the choice of programming language and tools for robotics has become more diverse and tailored to specific needs. We will talk about it separately in other videos. And the shift towards high level languages, why we have chosen Python instead of C and C++, there is a history behind it. Okay, so and the open source frameworks, of course, and integration with artificial intelligence or AI and IoT especially, has how it has enabled development of more complex and sophisticated robotic systems. We'll see in the future video. So stay tuned and keep watching Woodenslet. And if you have not subscribed yet, please subscribe. It means a lot to me. If you have already subscribed, also thanks for your support. See you in the next video. Till then, take care and stay safe.